Hi guys, today I want to show you guys Word2Vec. We're gonna look at what it is, how to use it, why it's useful, and maybe learn a little bit about machine learning, and in the end I hope to demo it for you guys. What is Word2Vec? It's part of Google's TensorFlow library. It's like a collection of machine learning tools for image processing and language processing. And this one in particular is used to find relationships between words. What do I mean by relationships? Analogies. Today I'm going to teach you how to cheat on your SATs. But just the analogy section. 2 seconds until the solution slide. It took me a while to do this one. But what about a more relevant analogy to these days? Does anyone know the answer? I know it's tough. I had to look it up. Okay. Nope, this is wrong. It's supposed to be Swifties. But my point is that analogies show relationships between words. Believers and Swifties are fan names of their respective celebrity. And grandiloquent to simple, that was in the first analogy, grandiloquent is a fancy word for fancy, so they're opposites. And I'm sure you can think of a lot of other analogies like actions or categories. Word2Vec finds these relationships with word embedding, which means it creates a map, which means it maps the words into 3D space, creating vectors. And in this word cloud, the similar words are close to each other, which means that the relationships have similar vectors. You can see here, country and capital, all the vectors are pretty much parallel to each other. And this lets you do cool things like adding and subtracting them to create analogies, to fill in the blanks of analogies. Here we have Japan is to Tokyo. You can subtract the vector and then add the Rome vector, and you'll find Italy. So we have a bunch of text, and we want to get this map of word vectors. How does it work? I can't explain machine learning or neural networks to you guys, but I'll try to be as I guess, clear as possible. If you take a look at what vectors are, they kind of look like this, where each row is a feature. So if you want to look at the first row, you can see that king, queen, and princess are weighted heavily on the feature, while woman is not weighted heavily. We can guess that this feature has to do with royalty. Or if you look at the third row, you can see that king is not weighted heavily, while queen, woman, and princess are weighted heavily. And we can guess that this feature has to do with being female. The computer doesn't know any of these labels beforehand, so it has to somehow lump them together and guess these weights. And how does it do that? It looks at the words around the other word. So Word2Vec would take a word and look at a window of words, which they call the context. So if two words belong in sentences that are similar to each other, that means they're similar. So we know that cat and dog have something to do with vets and flea medication. It does this through two different algorithms, which are the two sides of the same coin. CVAL, which means continuous bag of words, looks at the context words and tries to fill in cat or dog. Skipgram looks at cat or dog and then guesses probabilities for all the other words if they would belong in this window. So I guess, for example, king, queen, and princess would the context would probably include maybe court or crown or beheading. And woman probably would not have those context words. The algorithm goes through a cycle where it guesses all these weights in the vectors and calculates the probabilities of the words, of all the other words being in a window, and then it compares it with the actual text. And that's how we get all these labels without having to put them in beforehand. Some cool applications of Word2Vec is search and recommendation engines. So if I run a job search website and I want to search a web developer, we can also give them searches for software engineer or programmer or front-end developer. Word2Vec is also used to add information to text for other natural language processing models because if in machine learning, if you process image or audio data, you can take pixels, and pixels will be comparable to each other because you have intensity of pixels. But words, you can't really compare them unless you map out their relationships. It can also be used in translation somewhat because if you map out languages that are similar to each other, like English and Spanish, similar words will be in similar relations to each other. So if you have cat and dog in English and you know the translation to cat is gato, you can take that vector and move it over to the Spanish map and you'll find the translation for dog. It can also be used for non-language related things because every word gets processed first into a distinct token. So you can find the meaning of emojis or product pictures because they can just be transformed into another word token. And I'd like to, I guess, do a test drive with you guys. I was going to show the TensorFlow. The library has a tutorial for Word2Vec, but someone wrote a node.js interface. So it is actually pretty simple if you want to test out different if you want to test out training your own vectors. Let's see what we have. Maybe I can open a new one up here. This way. Gotcha. Let me show you my terminal. So first you npm install word2vec, word2vec, I think. I should already have it. But you can just create a variable for word2vec. Let me save this as trainer. And you'll have to train this will be for, I'm going to write 2 files, one for training and then one for loading up the models. So first you have to kind of fix up your data, take out punctuation or unusual punctuation, and create phrases. So if there is a phrase that occurs a lot together, like Barack Obama, that'll concatenate into one word. What do we want to try first? Let's try Pride and Prejudice. Text. I'm going to copy over training parameters. You can see here, you can specify the window, so the number of words that you're looking at before and after the word. This is where you decide to use continuous bag of words or skipgram. And this is the size of the vectors, or the number of features. Text. I think this is the callback. Hopefully this will create the trained vectors. Trainer.js. Uh-oh. Oh, thanks. Pride. Processed. Pride and Prejudice. And pass in the callback when it's done to train it. Cool. So we created this, should be here. Doesn't look like it's saving onto the model. pp.text. Let me try to just train it now that we have it. Maybe I have to make it first. Hold on. Trained. Oh, training parameters. Sorry, guys. And you get this giant file with all the vectors for the words. And we can load the model, trained pp.text, and print the words, the size, and find similar words to Sherlock. We could find analogies. Analogy. I didn't hook that up yet. But let's see if this works. Load model, train pp.txt. Thanks. Sometimes out of dictionary. Okay. Oh, Darcy. I really wanted to show you guys analogies, but I don't have internet, so I can't look up the API. But yeah, this is how you can find analogies with Word2Vec.